following podcast is for informational purposes only. The contents of this podcast do not constitute tax, legal, or investment advice. Take responsibility for your own decisions, consult with the proper professionals, and do your own research.
Web3 really coming up alongside Web 2 in power and influence and then surpassing it. I think Web3 definitely has that potential. So in that world, the graph is just powering and indexing so much data. Like what we're doing right now is not even close to like the potential that could be done on blockchains and like what could be indexed.
We're like astronauts floating in the space of time.
Welcome to the GRT IQ podcast. Today I'm speaking with Dave Kajpust, a blockchain engineer with Edge and Node. If you've ever been in the Graph's Discord or attended any of the town hall meetings, you already know that Dave is a highly regarded member of the Graph community. Our conversation is incredibly insightful, and Dave covers a long list of important topics and ideas, such as his role as blockchain engineer, what the early days were like when helping to build the hosted service, and how he thinks about important concepts like indexing layers, nodes, and the difference between L1 and L2 blockchains. We started the conversation talking about how Dave made his way into crypto and eventually to the graph.
I got involved in crypto about 4 years ago, and really it was a time where I was trying to figure out what I wanted to do next in my life. I was a mechanical engineer. I just came out of university and I've been working for about a year, but I knew it wasn't really what I wanted to do for my life. And so I was quickly trying to figure out what to go into. And I quickly honed in on getting into tech because it was clearly a fast-paced environment. And then I was trying to figure out what I would want to do. And so I was researching a lot of things in my spare time, looking into VR and AR, looking into a bunch of other like things on the horizon. And then crypto was kind of this thing that at the time was very small, but I started reading about it and I thought that was pretty interesting. And then I started to teach myself how to code. And it was before I'd even decided about crypto, right? I was like, well, it just seems like coding can really get you anywhere in tech, right? And then I actually liked it a lot. Like I was just doing it at nights and on the weekends, and I was really enjoying it. And I realized in a couple of weeks, I was like, hey, this is obviously a huge thing if I really like what I'm doing, because I didn't like my job. So I decided right there, I was like, hey, I'm going to quit and become a developer. Signed up for a boot camp and went and did that. And after the boot camp, things were just going well. And this was around like 2017, and crypto started to get a little bit of energy. And I decided I would teach myself Solidity. And I did that right away. And it was really a time when Solidity was brand new. So then I got into crypto. I got skills that were hard to come by. And then ever since then, it was kind of like it's been fast paced ever since then, right? Like the whole entire crypto space is wild. And that's kind of how I got my start. And, the second I was in crypto and got my first job and started understanding how it all worked, it was like I was sucked in. There was no way to like pull me out from the vortex.
Is there a meaningful difference between what is understood as a developer outside of crypto and what a developer is inside of crypto?
It's a great question. I would say there's really, at a high level, we're all developers at the end of the day that are specializing in specific things. Like if you ask me, if some other developer ever asks me like, hey, can I get into crypto? I'm a iOS developer or I'm a Java developer. I always say like, yeah, you can. Like there's nothing in this world that you won't be able to understand and like pick up. So in that sense, like really anybody can get in there. But of course, like every single section of tech or like being a developer has its own kind of uniqueness. So the thing about being a blockchain developer is really understanding how blockchains work, which is a learning curve for people. It's this, global public decentralized kind of database that people are writing to and reading from. And once you understand that, a lot of the blockchains kind of like there's this similarity where you could go be a developer on Ethereum, you could go be a developer on Polkadot or Cosmos because you understand the concept of how like blockchains work. But then in every single specific blockchain, there's going to be specific things that you need to understand. And so like if you're working with the EVM, you'll probably want to know Solidity or Viper. And once again, there's nothing special about those languages that people can't pick them up. But it is really the biggest mind shift is thinking about security, because as we've seen like hacks over and over again in the community, and it's really like a lot of standard practices have been picked up and people are following them, which is good. But you still see people coming into space and, they get wrecked by using a decentralized oracle like Uniswap or SushiSwap, and they're reading from there. And it's easy to abuse those decentralized oracle prices with flash loans. And that's just something that, some people don't really pay attention to. And then those hacks happen again. But at the end of the day, like it's all part of the ecosystem and there's going to be hacks either way. So it's all part of the learning experience. So, any developer who's not in crypto, it's very possible to get into, but I'd say it's like really important to pay way more attention to security in this space as a developer.
So much of what's happening in crypto is still very new. And I'm curious if you would also categorize the role of developers within crypto as something very new with a lot of opportunity for change.
Yeah, it really is. The whole entire blockchain development space, although it's very different and a lot better now than it was like back in 2017, and it's a lot more mature, it's still very like young and nascent. And when I think about like developers who want to join, there's really not even that much to learn in Solidity. It's a pretty concise language, although the devil is in the details, and like that's where all the hacks can happen is making a small error, right? But really, the whole entire space is young. I would probably compare it, even though I wasn't a developer back then, I would probably compare it to like iOS development in 2008 or something, maybe 1 year after Apple released the iPhone. And it's like people could just come along. There's very few experts in iOS in 2008 because it's only been around a year. In crypto, there's a decent amount of Solidity devs out there, and then like other kind of crypto devs working on other chains. But still, there's clear like severe shortage of blockchain developers right now. And that's just because in the last 2 years or so, since the last bull market in 2017, 2018, there was a bear market and not a lot of people came and joined because not a lot of companies were growing. And now all of a sudden in typical kind of crypto fashion, everything is going up like crazy and exponentially. And that has like massive effects on all these companies and all the people working at them. And if there's a shortage of blockchain engineers. And so if right now if you have any skills and you're a blockchain developer, you're in high demand. And it'll continue to be like that. But I also think there will be always be these cycles and such. So either way, there's going to be a lot of space in the blockchain developer world that is going to like continue to grow. And I can only imagine in the next 5-10 years, this role will continue to be increased worldwide.
So can you take us back to when you first got involved with the graph?
What ended up happening was I went to a hackathon in Buenos Aires. It was ETH Buenos Aires 2018. And so I flew out there by myself, and I was kind of like in between jobs, but I was also doing a lot of research on my own. And I was actually very interested in Cosmos at the time. Cosmos and Polkadot were both fairly new, but they were going with the whole inter-blockchain communication stuff and creating different like blockchain specific applications that were talking to each other. And I got really interested in that. And I started learning the language Go, which is what, the Cosmos SDK is written in. And so I was at this hackathon and I was doing that. And I just met Yaniv, one of the founders of the graph, right? And I met him and just had a couple good conversations with him at this hackathon. And I didn't think too much of it. And he was explaining the graph to me. And this time the graph actually was not really public. Maybe they had a website, maybe like one blog post, but I had never actually heard of them because they had just kind of raised funds and they were just expanding and like they were going on their first kind of like hiring spree. And so they reached out to me and said, "Hey, do you want to come work with us?" And I said, maybe, because I was working on my own stuff with Cosmos. And I said, reach out in a month. And they said, sure. And then they reached out in a month and kind of asked me if I would come on and join. And I still didn't really know too much about the graph because there still wasn't that much public about it. But I talked to all the founders and understood what they were talking about. And I found, the whole problem that they were trying to solve really interesting, Web3 and indexing. And it was still a bit new to me, but I said, sure, like this seems really interesting. There's a lot, I think, for me to learn here and to help out on the team. And then so I got involved as a contractor, but very quickly became like working there all the time. And essentially, it really took, a few months of working there to really understand the vision of the graph, because it was very early back then as well. It was all this Web3 stuff. The graph was one of the few teams back in 2018 that had really thought through Web3 at length and very in depth. So I actually had to join the team and be part of it before I could realize, the potential that the graph held.
Something you mentioned there is a common thread with a lot of the guests on the GRTIQ podcast, which is they had a conversation with Yaniv Tal and it drew them towards the graph. What do you remember about that conversation?
I think what Yaniv did was he, very smartly went around to these hackathons or other events and just talked to people. And, him and I had a great conversation, not even really focused too much on the graph at that hackathon. It was just focused on crypto and Cosmos and things in general. So, you build a rapport and you realize, all right, this graph thing sounds like a pretty good idea. But even at the time, I didn't have much to dissect because it was just a conversation that we had. And then it really, what drew me in was meeting with Yaniv and the other two founders, Brandon and Giannis, the first time they kind of interviewed me. And it was just clear they all had a really solid vision. They're all really smart people and they were highly motivated and hardworking. And it's pretty rare to find a group of three people like that who kind of check all those boxes. So right away, I kind of realized that, the graph had this potential. And it still was going to take me a few months to figure it out fully. But I believed in the people behind the potential and what they were saying and kind of their ideas. So I think the combination of the idea and taking a while for it to percolate in my head and then the people behind it really is what drew me in.
I've seen other interviews you've done where your role at the Graph and EduNode has been described as blockchain engineer, researcher, and a host of other things. I'm curious how you think about what your primary role is.
I think definitely more so at the end of the day, I'm a developer or like a blockchain engineer, first and foremost. And then secondly, by necessity, I'm a researcher in a sense, because the blockchain space is like so fast paced changing, like you have to kind of research what's going on.
So Dave, I think listeners would be interested in knowing what the early days were like at the Graph when you were helping to build the hosted service. What was that like?
The Graph really kicked off publicly as the hosted service. We did launch the Graph Node software beforehand, and then we were going to hackathons in late 2018. It was the ETH Berlin one in 2018, September-ish, that we first released the Graph Node and allowed people to build subgraphs. And it was this new kind of paradigm that developers could use. And everything back then was really raw. All of our documentation, like we literally had to sit with the teams and help them at the hackathon because there just wasn't clear enough instructions and there were still too many bugs for anybody to accomplish completing a subgraph by themselves. And at this time, I didn't even really know much what a subgraph was because I've always been on the smart contract side and the graph node, right? This is what the software that our node operators and indexers run around the world. It's all written in Rust, and it's a client that does all this indexing of blockchains. So I'm not a Rust developer, and I didn't understand really how the internals worked. But then what happened is we launched, and we had these subgraphs, and then there were all these protocols that were public, right? Like Compound, Uniswap, I think were both public around that time. And then we started to work on the Graph protocol smart contracts, but then we also, and that was something that I was working on. And then we also decided we were going to launch this hosted service. So what is the hosted service? It's essentially like, the MVP or the proof of concept or just like our ability to showcase what subgraphs are, because we built this powerful technology, but of course you need to get people to use it to see how powerful it is. So we could have launched the decentralized network and had nobody that had built a subgraph in the past and it had very low adoption, but we decided to go with this hosted service idea, which is really just a graph node, hosted by us, and anybody can deploy a subgraph to it. And we're going to maintain that graph node and make sure that all these subgraphs are running all the time. They can be queried. We're improving the performance, making developers' lives easy in the blockchain world. So we launched this hosted service really at Graph Day in January 2019. And for that, what I did was I actually built a lot of the first subgraphs. So, the first 7 or 8 subgraphs that we kind of launched that week was, Decentraland was on there, Compound was on there, Uniswap was on there. I can't remember the other ones, but there was about 8 of them. And really, that's when people started to come in naturally. Everything had to be, we were bootstrapping it ourselves. I was building subgraphs for other teams, and then teams started to hear about us and started to build these subgraphs. So then the hosted service starts to take off and people are using it and realizing how much it actually saves developers time. And so we're going along with the hosted service for a really long time. And of course, that's what a lot of people thought of for the graph, because that's what we had. But in the meantime, we were working on this decentralized network, which a lot of people knew we were working on, but details were not public for a while. And then essentially, over the time, this is more so 2020, a lot of work starts to be done on the decentralized network, and then the hosted service was there, and that's when it really started to get a ton of adoption in 2020. And we're still running the hosted service today. So there's the decentralized network that is live right now, has 10 subgraphs on it right now. And then there's the hosted service that is still up there today and accepting subgraphs for developers to deploy on. And so the hosted service is going to be there for a while still as we get the decentralized network balanced out, as it's still in the very early days, and we're increasing its capacity and efficiency every single day.
The GRTIQ podcast is made possible by a generous grant from the Graph Foundation. The Graph Grants program provides support for protocol infrastructure, pooling, dApps, subgraphs, and community building effort. Learn more at thegraph.foundation. That's thegraph.foundation.
This is GRTIQ. Each week, we introduce listeners to different members of the Graph community and ecosystem. Our goal here is to engage listeners by telling the stories and sharing the insights of those helping to build the Graph. Please consider supporting this project by leaving a review wherever you listen to the podcast, or by sharing your favorite episodes on social media. And don't forget to visit grtiq.com/podcast for detailed show notes. Thanks for listening. How should we think about some of the differences between the hosted service and the decentralized service?
It's not really too different, but I can explain how it is different, because obviously there are key differences between the hosted service and the decentralized network. So both of them are just running the GraphNode software, right? So they're running GraphNode. It's indexing all these blockchains out there, like Ethereum, like all the other ones we've added support for in the last couple months. But the key difference is, the decentralized network it's over 100 right now, but indexers around the world running the GraphNode software who can pick up these subgraphs and run them. The thing that they're doing differently is they're running this thing called the indexer agent. And all the indexer agent really is doing is interacting with the decentralized network, which is running on Ethereum. And I'm trying to keep this simple. And basically, the indexer agent is doing the blockchain transaction, right? So a lot of people understand what the delegators do. You just put your stake on a specific indexer, and then the indexers stake on subgraphs to actually index those subgraphs. So the big difference between the decentralized network is the number of nodes that are running compared to the hosted service. It's over 100 versus 1, essentially. And then it's also actually interacting with the decentralized network, which is part of where the graph token is used to signal to indexers which subgraphs to index. So that's really the difference. The graph node is just this node running in the cloud. It's supposed to accept all of these subgraphs, just, no questions asked. There's really no decentralized marketplace there because it's just one machine in the cloud that's accepting deployments of subgraphs. Whereas the decentralized network is this complex marketplace of interactions between delegators, indexers, and curators. So at the core, that's the difference that the decentralized network is doing. And that's the difference that node operators are doing, is they're trying to follow the decentralized network and the actions of all the members in the graph network, as well as just index subgraphs in a really efficient way and like make sure that they have uptime and they're serving queries properly.
As it currently exists, most people think about consumers of the graph as dApps or decentralized applications. How should we think about the future consumers of the graph? Will it always be dApps?
Good way to think about it is like the dApp developers today are the most obvious use case because we have all these, Ethereum and other blockchain applications that are running, and like blockchains are really not built for like being able to serve up queries of blockchain data very efficiently. Like when you think of Ethereum and the Ethereum mainnet right now, it's not a good piece of software to return complex data from queries, just because what is Ethereum mainnet trying to do? Well, it's trying to be this decentralized peer-to-peer network and traverse these blocks across the nodes and make sure that mining happens in, it's about 13 seconds a block, and ensure that uncle blocks are rewarded for people that are doing this extra work. And there's all this really tough technology that goes into building a proper blockchain that is really what, the Ethereum clients like Geth and Open Ethereum are trying to optimize for. They're trying to be good blockchain clients. They don't really care about the ability to serve up complex queries because that's just, you can't do everything, right? You have to choose what you specialize in. So then the graph came along and is really indexing all of this information off blockchains. And most blockchains, if not all blockchains, are going to have this problem because you can't, like I said, you can't do everything. So then the graph really becomes this layer, right? This indexing layer on top of the blockchain ecosystem. And right now, it is very clear that dApp developers are the ones who are benefiting. But in a world where Web3 is very mature, however many years down the road that is, I'm not sure. But when it's mature, you could imagine all this data that is being shared in a very different way from the models that we see today, which is basically all the data is owned in data centers by Google, Facebook, Amazon, all the big companies. And they really own it and it's yours. And it's this weird model that isn't ideal. It got us very far, got us to the 2020s, and it did a lot of good things for society in some ways, but now it's kind of like backfiring in a way, right? And so Web3 is this open data vision, and you can imagine there's so many paths to go down here, but really some of the more important ones I think of immediately are just open data. One that we're actually seeing use for that is not dApp developers today are like researchers or people trying to like trade in the markets, right? Like there's a lot of financial data that you can extract from all blockchains right now. And so people are using the graph and doing analysis in the same way that people have done analysis on stock markets before, right? And that's expensive data to get a hold of. And if you have the ability to get that data, it gives people advantages, which is why we're seeing that kind of data being used right now, financial data with the graph. But really, Web3, you could imagine a world where people own their own data and are able to either give permissions to send it out to different apps or like sell it to some sort of surveyor or somebody doing data, kind of like analysis and surveys. And what ends up happening is the model really shifts, and it's really this decentralized data that either people can own or businesses can own or smart contracts can own. And there's a bunch of new ways that the economy can shift around that. And I'm not the expert in totally explaining that, but there's a ton of opportunities that change. And really, when that paradigm shift happens and people are using the graph to query all of this information, it really becomes like any information that you can put on the internet. And so dApps right now are mostly confined to DeFi apps. That's what most people know. But when we get identity apps, a perfect example, and one that I think is hard for most people to think about, is a real decentralized identity. And, I'm also not an expert here, but what I like to think about is passports have really only been around for maybe, like I'm probably screwing up this timeline, but about 100 years. And they only really got taken seriously after World War II. But now it's kind of ingrained in everybody's head that like you need a passport to travel. But of course, like technology changes and society changes. So do I really think that passports will be the main way of traveling in 50 years? I actually don't think that. I think it'll be enrooted in some digital identity online. Maybe you'll have both. I don't know. But all of a sudden you can imagine that like your identity, as well as things like your financial credit, could be on chain, and it could be data, and it could be powered by blockchains, and it could be indexed by the graph. And now you have this whole entire world that is not just focused on DeFi applications, it's really any blockchain data.
The graph is often referred to, when you zoom out on what it does, as an indexing layer. How should we think about what an indexing layer is?
The classic examples that people use as indexing layers that are like, analogous to the graph are like a phone book or what Google does. So you can start with a phone book. Everybody, let's say the United States, right? I think it's 330 million-ish people live there. And if you want to find one person's number and you had no guide, you have to start doing it one by one. And that'll take you a really long time. And so the obvious thing is make phone books for specific cities or specific counties, organize them by some sort of thing that humans are going to get, right? And that is usually by name, right? So A to Z. And now all of a sudden you've taken a whole set of 330 million people and you've been able to narrow it down with a couple of rules. And you can now like index that and put it into this nice phone book. And now you can probably find one number in under a minute rather than what it would take you, hundreds of years to search through 330 million. That's a very simple example. Now, when you think about Google, it's really, I wasn't even around when Google was, I was alive, but I wasn't using the internet when Google was really being created, right? In the late 1990s. And there were these kind of search engine wars, right? And so I don't remember this, but people used to have to search for websites directly in the search bar. Like there's just no magic Google or search engine that could solve everything for you. It was a very manual process, or people would make websites that had good links. And that was the best. You'd go to this one website and it would show you 100 really good websites that you could link to from there. And that was kind of the extent of it. And so where are we now today with blockchain? It's the same thing, right? The blockchain is just as hard to traverse as the base layer internet, which is, like HTTPS and a couple of these other protocols. Blockchains are just as hard to read from, if not harder, than HTTPS and like TCP IP and all that stuff. And so really, where are we in indexing? When we're indexing blockchain, we're basically trying to serve up information in a more readable way, in a way that people can digest, that a human can come to and almost give like a verbal command, the same way that you type into Google and say, I'm looking for the best food in Singapore in this specific area, and you're going to get a great answer. It's like you want to be able to do that with blockchain. And we're really not there yet. And you can imagine how long it took Google to get there. That might take that long for blockchains to get there with indexing in the graph, right? But there's this huge space to improve. But like Google is still improving today, over 20 years later. And the graph is improving like crazy today and will still be improving 20 years later from today. And basically, where are we today in like the indexing layer in the graph? It's very early. We're like, we could say we're at that point where we're just setting up simple websites and with links to 50 other websites, and like the search engine wars haven't even started. Like that's kind of where we are in blockchain indexing. So what is the potential of this indexing layer? Well, right now it kind of is reading, it goes on top of the blockchain, Ethereum, for example, and it's allowing people to both read into and understand the data in Ethereum in a more human digestible way. This is, indexing. It's a catch-all word, but it's doing all this interesting like transformations and changing of data. It's taking this computer raw data and giving it into human digestible data that allows humans to make decisions and allows humans to get insights. And so this indexing layer can keep getting like more and more and more complex. And that's really, today we're still very early. We're getting financial data. But there's a world where as more data comes into Web3, there's just an infinite amount of connections that can happen in indexing. And that's kind of the potential of this indexing layer. It's like, how can you take a huge amount of data that is basically computer data and unorganized and hard for humans to read, and present it to humans in a way that shows insights they wouldn't have seen, connections they wouldn't have seen, understandings of how the world works in blockchain. And then with that data, it's just a feedback loop of improving decision making, improving, blockchains overall, and what we can do with them.
As a follow-up to that, how can you help us better understand the difference between an L1 and L2 blockchain?
There's a lot to unpack here. And what I'll try to do is keep it in the context of the graph specifically, because I don't want to get too general and explain, Ethereum L1 and all these L2s. So I'll keep it general, but always relate it back to the graph. So L1 is, Ethereum mainnet is the perfect example. And that's what the graph decentralized network runs on today. And then there's L2. And so some of these L2s you can think of are like Arbitrum, Optimism, Starkware. These are, well-known names in the space. All of them are either launched or launching their mainnet soon. It's getting very close. And then there's also these side chains, and many people might have heard of some of them, like Polygon, right? And the side chain is kind of like an L2, but not really, it's not actually, right? By definition, they're different things. But both an L2 and side chain are trying to give more transactional throughput for blockchains and for users. So Ethereum L1 is slow. And part of that is the way it's built, and part of it is being an L1. And everybody knows now that the fees are very expensive to use Ethereum. And there's been times in the Graph network where fees are, over $100 or more, depending on the price of Ethereum and the gas price at the time. And so that is obviously not a sustainable situation for the network, or it's working right now, but you also don't want to have the Graph network vulnerable to these wild swings in Ethereum prices and gas prices, because then our delegators and indexers are suffering because of that. And if you have to pay more than $100 to delegate, then all of a sudden you have this friction in the decisions you can make, because you really know that you don't want to move your delegation for maybe as long as possible. And if you're an indexer, you want to hold your allocation open for 28 days to not pay these crazy fees. So obviously the Graph is researching, and this is something that some of the stuff that I'm working on is L2s that we can use and scale to. And so how do L2s scale, and why are they offering more transactional throughput? And that's what the difference between L1 and L2 is, to answer the core of the question. Is L2s are these solutions that are built on top of an L1, such as Ethereum, and they're anchoring back to L1 in a way that allows people, because if you move your tokens like GRT from L1 Ethereum to L2 something else, you're effectively transferring that to another ecosystem. Probably the best analogy would be when you transfer your GRT or your ETH to Binance. Now Binance is in control of your tokens, and you're trusting them as a third party. Now, when you're doing the same thing when you move to an L2, except the L2 is not Binance, a centralized exchange, right? The L2 is a decentralized, basically kind of almost like another blockchain. A proper L2 that's mature should have, many different node operators that are also running this kind of state machine, or basically a blockchain that is determining what's happening on L2. So you could imagine we move staking from L1 to L2. And what happens is now the staking logic is being done on this L2. And it's a lot cheaper because it's less dense with people who are trying to use it. You can imagine Ethereum L1 as the busiest highway in North America with everybody trying to get on it. And then what you're doing with an L2 is you're building a new highway, and you have less people on there. So you're moving a little bit faster, but you're also trusting, the people who built that highway, which are these L2 node operators. And you also, the thing is, you want that L2 highway to be able to have an on-ramp and an off-ramp. And the off-ramp is important because you want to be able to get back on L1 if L2 nodes collude, right? And it's the same thing as early days Ethereum or even Bitcoin. It was so early that collusion was easier. And so an L2 that gets launched in any of these protocols you're seeing today, they're going to be less secure than Ethereum layer 1. It's just natural. How do you get more transactions? You can improve the technology, which is what a lot of these L2s are trying to do, but you also just have less transactions happening on them, and more, which gives an application more room to use the L2 nodes who are running the software. So really, that's what we want to see with L2, and that's the research we're doing. We're trying to get parts of the protocol onto an L2 that we deem the one that is likely to be the most successful. And this L2 should have a lot cheaper fees because it'll also be less secure. But what we really want from that L2 is lower fees. It'll be less secure, but we also want the ability to have that fallback, which a lot of L2s provide, which is like they anchor transactions on Ethereum L1 that essentially will let you withdraw your tokens to L1 if something goes wrong with the L2. It could be collusion. It could also just be the L2 blockchain kind of gets corrupt or broken and you have to exit somehow. So there's this difference that is, they're both, at the end of the day, they both act like blockchains, L1 and L2, but L2 is kind of connected to L1 and is supposed to be a faster route, which means a cheaper route for your kind of logic that you want to run on a blockchain, and you want to have it anchored to L1.
A lot is discussed about what impact Ethereum 2 might have in the crypto space. Can you explain what Ethereum 2 is and how it might impact members of the Graph ecosystem?
So yeah, Ethereum 2 is the next big kind of goal for the Ethereum Foundation. And Ethereum 2 is a completely different blockchain built from the ground up. And the whole point behind it is Ethereum 1 was built and released in 2015, and they've been doing upgrades and patchwork to it over the last 5-6 years. And it works very well. Obviously, Ethereum's had a lot of success, but everybody knows that there is better ways to just make the underlying core technology better. And what Ethereum 2 is really trying to do is they're trying to build an actual decentralized network. And so they want, the way they're designing it, they're trying to get thousands and thousands of people to be node operators around the world. The last that I read, you have to stake 32 ETH to be a node operator. And the whole goal of ETH2 is to build this better blockchain from scratch and allow people to migrate to it, allow it to be decentralized in the fact that there's a lot of people around the world, thousands, running the software. And that really protects you from, collusion or attacks by nation states because it's just more decentralized. And if you look at some of these other blockchains, like even Ethereum and Bitcoin today, obviously have some centralization around their mining pools. But even if you go the level higher to the people who are participating in those mining pools, I don't know the number myself, but it might only be dozens or maybe 100 or 200 really big Ethereum and Bitcoin node operators around the world. And like, that's not as decentral as we could hope. And if you look at some of these other blockchains that are trying to run a lot of throughput, I guess the perfect example is like Binance Smart Chain. It's really only like 9 nodes or something, or maybe even less. And they're just putting so much throughput on there and it's really centralized and they're not hiding that at all. But it kind of goes away from, the whole point of having cryptocurrencies. It's the Binance is just somebody who is centralized and has released a coin that is money, and you can never have that money kind of replace, the money that nation states have. You kind of are just in the same problem where you have a small group of people who are deciding how this money is distributed. So that's why like this whole decentralization thing with blockchains is really, really important. And that's why Ethereum's vision right now, and this is my opinion, but in the whole entire space is like the most ambitious still. You have a lot of these Ethereum competitors coming up, but none of them are really going for this, trying to get thousands of nodes around the world to run properly. So that's what is super duper exciting about Ethereum 2. And I think it's what's keeping a lot of people 100% all in on Ethereum is because of the vision and like the goals behind it. And what is ETH2 going to do for delegators in the graph? Well, in the meantime, we're going to be trying to move our protocol to L2 and getting some better performance for fees. But of course, we're hoping that Ethereum 2 comes out as soon as possible, which I forget the roadmap, but I don't think it's going to be fully released for more than a year, maybe 2 years. But we want that to happen. And then of course, what will happen is Ethereum 2 will be a layer 1 blockchain that has a lot more throughput and a lot more power than Ethereum is today. And there will still probably be L2s that branch to Ethereum 2 and all these interconnected blockchains and such. But ultimately what's happening with ETH2 is, there's going to be this improvement in blockchain technology, which is just going to be great for the graph and its ability to operate the decentralized network. And it's going to be great for all other protocols in the ecosystem.
Speaking of the graph ecosystem, how important is the role of delegators in the ecosystem?
Delegators are extremely important to the graph ecosystem because they're kind of like the largest group of people with the most kind of influence in a way, because they're the largest group of people. Like, there's always going to be more delegators than there are indexers. And at least now there's more delegators than there are curators. And so delegators really need to send a signal to the network on indexers who they believe in. So if you're a delegator, you are delegating your tokens to an indexer and you believe that this indexer is going to pay you a reward, right? So you could be an indexer yourself and run the indexing node and get GRT tokens from the inflation rewards. Or you can be a delegator and delegate to an indexer, and you're going to get the same amount of rewards, except the indexer is going to save a little bit for themselves because they're doing you a service, right? You're also doing them a service by giving them more capital to index on allocation. So there's this symbiotic relationship. And the delegator's whole goal is to make the best return for himself, and the way to do that is to pick the most honest and best performing indexer that is going to give them the best rewards. So all of a sudden you have this self-balancing system where there's two key operators in the system, delegators and indexers, and they want the best for themselves, but they also know that it's in their best interest to make the network work. And so the good thing is, if you have like an indexer who's evil in the sense that they're just doing bad things. They could be purposely attacking the network or putting up subgraphs that are really hard to index and throwing people off on purpose. Or they could be taking funds directly from delegators by changing the rate of fees that they share with delegators. And so naturally, the delegators should be able to wean out the bad indexers by not delegating to them. This gives the bad indexers, a bad reputation and less power in the network. And there's a good chance that they'll just leave eventually. Or it kind of like the whole aspect of indexers and delegators just makes for an environment where it's actually much more advantageous to be a good indexer and a good actor in the system than it is to try to like extract value from the system and provide no benefits to everybody else.
A common question I like to ask on the podcast is, what's your advice for delegators when selecting an indexer to stake their GRT with?
Yeah, this is a great question. And I think it really depends on what kind of delegator are you. So I could say right now, like confidently, there's enough information out there on the blockchain and you can analyze who the good indexers are. And then you can also do kind of like the social engineering or the social work to talk to indexers and talk to other delegators and find out yourself. So there's two ways to really determine where you should delegate to. You can look at the facts, the data on the blockchain, read the graph network mainnet subgraph and see what indexers have done in the past, or you can just talk to people. And so that gives delegators who are technical and non-technical the ability to determine where to put their tokens. And a good thing to think about is like, if you're a delegator, you're making an investment to one of these indexers. And it's just like you would if you would invest in anything in your life, right? If you want to do your due diligence, you want to make sure you put it in the right place. So there's simply that. If you put in the work, you can figure it out. And so with that aside, it's like, how do you actually pick who's a good indexer? I'd say the easiest thing to do is to just go into the chat and talk to the indexers. There's a lot of active ones that make it very clear that like what they're doing, and they will answer your questions, and you kind of get this trust in them. And if you want, you can search the Discord history chat and you can see how these indexers have been talking. If they've been answering people's questions for 4 months, you can read back and see like there's a lot of confidence in them. And then you can be pretty sure that they're going to act right and act properly if you delegate to them. And then the second thing you can do is you can look at well-known names in the indexers space. So there are a couple big node operators in the space who are probably going to follow the rules and do a good job because that's what they're building their brand on. After that, you can talk to delegators specifically and figure out who they like. But then it gets into like, if you really want to figure out the best place to put your tokens and delegate them, and you really want to find like how you can get your best return, there's probably a difference of between like 2 to 10% annual earnings that you can get on average for where you're putting your GRT, depending which index you choose to go with. And that's where it comes down to really understanding the economics of the graph, reading the data, and taking your time to crunch the numbers, right? You can look at how well an indexer has performed to other indexers with the amount of GRT they had. Now, that data is a little bit harder to get. We are working on making a lot of this data more available to people through the subgraph, but it just it takes a lot of time. So a lot of the stuff would take a lot of expertise to figure out yourself. But my advice in general to delegators would be start with the people or the indexers and the delegators and the channels and do your work just by asking questions. And you should be able to find a pretty good answer. And then if it's really important to you to get the best return possible, start crunching the numbers. And, you can use our website. There's a couple other websites that show stats that are built by the community, and they have more information. You can read from our subgraph directly and build your own models, and you'll be able to get a better return. And so that's kind of my suggestion. The best thing to do is just put in the work at however much you think is worth it. If you have a lot of money on the line and you think it's worth it for you to do the extra research and crunch the numbers, then totally do that. But if you're putting, a small amount of GRT in, you're not too worried about it and you don't really know how to analyze that data, just talk to people, figure out the best indexers that you trust, and then just delegate to them and you should be fine.
Hi, this is Dave Kajpust with Edge and Node, and I'm a blockchain engineer. If my conversation with the GRT IQ podcast has been helpful to you, then please consider supporting future episodes by becoming a subscriber. Visit grtiq.com/podcast for more information. That's grtiq.com/podcast. Thanks for listening.
GRTIQ.
Something I've been thinking about lately is the relationship between curators and indexers. If a curator is out signaling on subgraphs, and then an indexer comes along afterwards and indexes the subgraph, why not make that one role so that you signal and then index at the same time?
It's a great question, and there's nuances to all these things, especially in these kind of open, decentralized protocols. So I'll start off by saying, yes, it is possible for an indexer to both be an indexer and a curator. There's nothing preventing somebody from doing that. If, for example, if somebody has a job at a company, maybe it's very well defined. You're a taxi driver. That's all you're going to do. You're not going to have some other job. And when you think about these open protocols, especially with finance too, and what blockchains enable, it's you could of course curate on a subgraph and then also index on that. The reason that we separate them is because it's two different concepts, really. Somebody can come along as let's say it's a dApp developer or even somebody who wants specific data about a blockchain. It could be a blockchain research company or a hedge fund, but they don't know how to run the indexing software. They don't know how to run GraphNode. It's actually kind of complex and they don't want to learn how. So they just want to put down GRT to signal that I want this subgraph index because I'm going to be reading data from it. And this is going to be valuable to me. So I'm going to put some signal on it. So that's a clear use case that is somebody being a curator. And then there's the clear use case of somebody being an indexer, which is hey, I really like running hardware. I've been playing around with, Linux for years and running different software. And now I want to do this. I want to run a graph node. Maybe they're running an Ethereum node or a Bitcoin node as well. And this is just what they do. And this is their expertise. And they're the thing about running a graph node is it takes all this complex understanding of how computers work and hardware works and, Postgres works and all these different technologies. So they're really two separate concepts, but you can combine them. And there could be an indexer who wants to be a curator and there could be a delegator who also wants to be a curator. These things cross paths. And, it's actually typical that you would see this in the real world too. It's, if you think about a bank, they are both lenders and borrowers. They provide liquidity and also take risks and do all these different things. And of course, banks have different sections in their companies, right? There's going to be the equity section and the bond section. But when you have these open kind of markets, you really can find yourself being a player in different roles and even on different sides of that role, right? Somebody could be a delegator and decide at the same time that they want to be an indexer all of a sudden. And there's no reason that they can. They just have to learn that skill and become a indexer and teach themselves how to run a graph node. And the reason a delegator might do that is because they see an opportunity to be successful. And that's the same thing that people might do in like the open market, right? If you want to trade stocks or something, you might just take that upon yourself. So I think definitely you're right that, you can be a curator and an indexer, and it's like, why don't you just combine that into one role? Well, there's definitely going to be people who are being both the indexer and the curator. But I think it is interesting and it makes sense to separate them out as concepts and explain them to people as that. And then just picture, if you step back, you can say, one person can be both those things. There's nothing stopping them, really.
Another question I ask every podcast guest is how they define or think about what a subgraph is.
So when I think about a subgraph, I think about it as a instruction manual to a graph node on what data to pull from a blockchain. So a subgraph is like this, at a high technical level, it's this open API that anybody can connect to and is going to return, queries that are defined by the subgraph ID, which the subgraph ID is defined by all the code that is built into creating the subgraph, and then the subgraph manifest and all this complex stuff. But really, at like a simple level, a subgraph is really a view on a specific piece of data or pieces of data of a blockchain that you want to look at, right? So if you want to think about the graph network subgraph and what it's looking at, or actually, let's use something else to move it in a more away from the graph to not confuse things with the naming of subgraphs, right? So let's say like the Uniswap subgraph. A subgraph is usually best defined by its manifest. And the manifest is going to point out specific things like, okay, so we're looking at the Ethereum mainnet as the blockchain. We're looking at these two smart contracts on the blockchain. Maybe it's the Uniswap factory, and maybe it's some other Uniswap contract that is published on the chain. And so you have these two Uniswap contracts that make up really the Uniswap protocol. And this is how you're like creating a subgraph. Now you went from a view of like what I talked about before, all the 330 million people in the USA, and then you want to have a phone book and you want to narrow it down. Okay, so we narrow it down to the subgraph manifest is like the phone book, right? So we narrow it down to just a specific blockchain. That's Ethereum. And now in the phone book, you narrow it down to a specific city, let's say New York. And then you narrow it down again. Okay, these specific smart contracts on Ethereum, which are really the Uniswap protocol. And then you say, okay, so now we're going to focus on Manhattan within New York City, right? And now we go back to the subgraph manifest. We have these two Uniswap smart contracts, and we want to look at these specific events that are emitted by those smart contracts, or maybe specific function handlers. And now what are we really saying? We're saying a couple specific neighborhoods in Manhattan, maybe like the Lower East Side, right? That's what we're looking at. We're trying to find just blockchain data in the Uniswap smart contracts with these specific events that are happening in them. In the same way, you want to find somebody's phone number in the Lower East Side in Manhattan, and you have a phone book that allowed you to get there really quickly. And now you have this subgraph manifest that allows you to get all the data for Ethereum. And that's essentially it. The subgraph is the view on that specific data. It's going to continue to grow from the day that the Uniswap protocol was launched to however long the protocol exists on Ethereum. So that's what the subgraph, that's what the graph node is going to be indexing. And it's well defined by that manifest. So you can expect to see the same data coming through over and over and over again. And that's basically the API. So now everybody around the world can confidently come to this subgraph and expect that it's going to shoot out this data in this format. And it's going to continue doing this as long as some graph node operator is indexing it. And that's a really powerful concept, right? The fact that this subgraph exists and you can tell by reading the subgraph manifest and the subgraph code what it's going to shoot out. And the other thing that makes a subgraph really interesting is somebody can choose, now that we have all that data, they can choose how that data is presented to you, right? And that's when the subgraph schema comes into play. So it's great that you have all this data that the Uniswap subgraph emits. But what does it mean if it's unorganized, right? You can just shoot it out and record it in a big database with no order. And then it's just as, messy as reading a book where the pages aren't organized. If it starts on page 100 and then the first page is somewhere in the middle, you can't read that book. The story doesn't make sense. But with the subgraph developer creating the schema, they're basically telling the world like, hey, this is the best way I think that people should read into what the Uniswap protocol is doing. And so that's really what a subgraph is. It's all the power of taking, the top level information and deciding as a subgraph developer, like what is the most valuable way to present this to humans in the world to digest.
Would you be willing to define what a node is?
Yeah, a node is simply like this. It's a good concept to keep in mind for all blockchains, basically. Like if you're running a graph node, you are running, the client software that is able to index all these subgraphs. And it's doing like a node it's essentially a computer that's running all these complex calculations. And it's like, if it's a big graph node, like the hosted service is going to be a really, really, really powerful computer, much more powerful than somebody's laptop, right? And that's all that these nodes are. And you could say the same thing for like Ethereum or Bitcoin or maybe like Filecoin, right? There are all these different nodes in these blockchains that are running the networks. And by and large, like they're either, when you think about a node literally in the physical sense, it's probably either exists on AWS or like Microsoft Azure or DigitalOcean. So it's a cloud infrastructure, right? But that's very expensive. So a lot of actual professional node operators are either going to rent the equipment from, like a data center. And that's a common pattern. Or you also buy the hardware yourself and install it at a data center. These are called co-located centers. And, if you can imagine like people spending tens of thousands of dollars on these nodes for like Bitcoin and Ethereum, they're hundreds of thousands, if not probably millions of dollars on some of the size of these nodes. And each node is trying to do a specific thing, right? So at the end of the day, a graph node is this computer running somewhere that is running the graph node software that is going to be optimized to be an indexing machine, which means people are going to choose specific parameters for this computer. They're going to pick specific hardware that they want installed on it. And they're also going to pick like a specific location around the world because a graph node has to be queried, and wherever you're located in the world is going to affect query latency. So really that's about it. Like it is a hard concept to think like what a node is because it's not clear and it's such a big catch-all term. But really at the end of the day, it's simply a computer running somewhere. And in the case of the graph node, it's a computer that's going to be optimized for being an indexer, which means it's going to be pretty powerful and it's going to have specific choices that the node operator chooses based on their own preferences and experiences.
So from the perspective of a blockchain engineer, if blockchain technology is successful and adopted everywhere, how does that change the world?
Yeah, it's a great question. The way that I've been thinking about it for the last couple of years is like blockchains are really like a Lollapalooza effect. This is something that Charlie Munger, which is like Warren Buffett's investing partner, has said in his book. It's something he's defined the Lollapalooza effect. And essentially it's, to keep it simple, it's just like a bunch of things coming together at once that have like these incredible feedback mechanisms that create exponential growth or just like very fast paced changes. And so what does blockchain bring that enables this Lollapalooza effect? And which is funny because like Warren Buffett and Charlie Munger both hate cryptocurrencies. And I'm using, one of their terms, but what does it mean for blockchain? Well, blockchains are bringing software development, which we have seen in the last 25 years is very fast growing, very open to tinkering and like fast improvements. And it's really a clear way for improvements to be made very, very quickly and like to happen at exponential paces. Whereas you compare the commercial airline industry where like they have so many standards and regulations to follow, it's so hard to like gain quick adoption. Same with biology and like creating drugs, right? Most drugs have to go through like multiple year trials and stuff, but software just grows as fast as people can build on it. So that's what crypto has. The second is people are kind of making money or making tokens out of kind of thin air. And you have this crazy effect where like it can just keep happening and happening and happening. And a lot of them end up being scams or people lose money on them. But the ones that are correct literally can be like go from nothing to something very quickly. And so we're seeing that play out as well. It's like usually capital is quite hard to get in new industries, but crypto's changing that because it's creating its own capital. Thirdly, we're seeing that the world is very well connected with the internet. And this is what we've seen in the last basically 20, 25 years of the internet going across the world. Back in the late 1990s for the internet bubble, it was really a bubble of tech companies that were focused in Silicon Valley because that's where it started. And that's where all the tech companies were going up with crazy valuations, and Americans were investing and Europeans were investing. Everybody's trying to get a piece of it, right? But the thing was, the whole world was not yet connected by the internet. Like people were on the internet and had email, like maybe your parents did if you were my age, but kids didn't have iPhones and stuff, right? Whereas fast forward to today, there's this new industry, blockchain that gets created, but everybody's already connected to the internet. So like the pace of innovation that is happening in blockchains is incredibly fast because you have people working all around the world. And it's not just concentrated in engineers in Silicon Valley. Like I think something that a lot of people are missing is like when I work with people external to the graph, it's like I'm working with people in Russia or in Europe or in South America. Even some of my coworkers are in these countries, right? And you even sometimes work with people in any country that you can think of, in any time zone. So you have all these people working towards this goal. And it's just happening incredibly fast compared to anything we've probably seen in the past. So when you kind of combine those three things, and the fact with like a lot of these people that you're working with are from, less privileged countries than such as the United States, right? And like they're very smart and they're very good developers and they're very good, visionaries for their crypto protocols. And like they're hungry to be successful because like a lot of these opportunities were not available in their countries before. So you have just this, perfect storm of all these things. Like that's usually a part of the equation that you need for success is hunger. If you look at people when they migrated to the United States, from Europe in like the 16, 17 and 1800s, like there was this hunger for like entrepreneurship and adventure and, growing something from nothing. And you could say the same thing about China since like the 1970s up until today when they had reform and allowed in some, capitalist ideas into their economy. And then you've seen this hunger in that whole entire population. And then you see this kind of hunger also taper out when countries get mature, right? So it's like, you see in America, because there's so much success, there's not that same hunger. Everybody is maybe, working less and more comfortable, which is not necessarily a good nor a bad thing. All I'm saying is that hunger increases the pace of innovation. And we're seeing that as well in the cryptocurrency and blockchain space right now.
It's funny that you bring up Charlie Munger and Warren Buffett, two individuals that I respect, but certainly antagonists of blockchain and the crypto space. How do you resolve that?
Yeah, it is interesting. It's like trying to figure out how, two people you respect a lot can dislike something that you so strongly believe in. But I do really believe in everybody has their specialty and skill when it comes to investing, and you can't be an expert at everything. So although there's obviously a lot of scams happening in cryptocurrency, and that's probably what scares them and makes them dislike it. But there were also tons of scams in like the early days in America when it was becoming this new country and like it was the Wild West. There were no rules. And so of course things are going to be the Wild West. Right now in crypto, there's no rules. So it's like it's basically a Wild West, right? Like you can show up to back in the early days of America. And the reason I say America is because how did Charlie Munger and Warren Buffett get rich is they got rich investing in American companies, basically. That was the horse that they connected to and then like rode to success. If they had been born in Europe or England, which, lost its power after World War II compared to America, and they were investing in British stocks, they wouldn't have had the same success. Now, in the Wild West in America and in like the 1800s and stuff, you could show up to a city and if you start a company, but I don't really know the details of this, but I imagine it was a lot easier to, like either just get shunned from a community or get murdered and nobody's going to be held accountable because there's no like forensic science back then. And so it's kind of similar to just getting like rug pulled today in crypto and losing all your funds. It's like there's nobody to really protect you right now. If you send your money to some scammer, it's gone. And so, of course, there's that kind of field is ripe for scammers, but it's also ripe for, visionaries and people who realize the potential of the technology. So that's what I think Munger and Buffett are missing is, of course, there's going to be a lot of scamming happening, but you have to focus on the potential that this technology brings. And you have to realize that it's not mature. Whereas when they started investing in the American stock market, it was the perfect time. Right after World War II, America was extremely rich, extremely successful, powerful middle class. And like, it was an easy scenario to invest in and it was safe. Whereas like crypto might be safe 10, 20, 30 years from now, where like people can actually come and expect never to lose their money and only for it to go up. And you're actually making decisions on what you're investing in based on some regulations and stuff. But we're not there now and it's the Wild West. And to me, that's also what makes it exciting. So like, even though that they dislike it, I'm definitely not discouraged by that at all.
I want to end with 2 questions. The first one is, what's your advice to individuals seeking to enter into the crypto space? And the second one is, what's your long-term vision for the graph? So let's start with your advice. What advice do you have for those wanting to enter the crypto space?
Yeah, my advice is always to people, if you have the desire to be a developer, then learn how to develop. Like there's so much demand in blockchain and being a developer there that like you will get a job if it's what you like and it's a desire that you have. I would almost guarantee that. But you have to like it, right? You can't just say, I want to be a developer and then take a course, a boot camp and hate it. Because like I went to, I've met people like that who went into it and they just didn't like it. And of course, like you're going to lose steam. You have to love what you do. So I would suggest people to do that if they believe they'll love developing. If they don't, there's a million other ways to get involved in blockchain and they're just as good, if not better for a lot of people, right? Like if every single blockchain company now or protocol is going like, has every single typical department or role that every other typical company in the world has today. And there's so much growth happening. People need analysts, people need marketers, people need salespeople, protocols need product managers and like HR, like everything you can imagine. So really, like I would 100% suggest people to get involved. The thing is, I really do believe it's going to continue to grow at exponential rates for the next 10, 20 years. We're kind of only seeing the tip of the iceberg for how blockchain is going to change how humans interact. But I will also say to people who want to get involved, to really get involved, you have to go all in and like commit and believe, because what's going to happen, and a lot of people did this in 2017 and 2018, is they got into crypto and they got a job, and then the bear market came and like a lot of companies got wiped out and a lot of people lost their jobs and then they just left. And if you're joining a risky kind of venture like crypto, you have to expect that there is going to be big swings in momentum and big downswings in momentum as well. So, prepare yourself for that, because if you join something and then there are hard times and you end up leaving, then you kind of like, you went down, you took the steps onto the field and then you just walked off when things got tough, and things will get tough. That's almost guaranteed. So it's like, go in with that knowledge. If you stick it out for 20 years, it's going to work out, but you got to be prepared for a lot more volatility than you'd expect in like a normal career.
What's your long-term vision for the graph?
The long-term vision for the graph that I see is really, a successful Web3 where we're getting a ton of data put through, blockchains and decentralized networks. And, Web3 really coming up alongside Web2 in power and influence and then surpassing it. I think Web3 definitely has that potential. So in that world, the graph is just powering and indexing so much data. Like what we're doing right now is not even close to like the potential that could be done on blockchains and like what could be indexed. So really what I see as success for the graph network is this protocol that is indexing all of Web3 and serving up queries, making it easy to read into all these blockchains. And it really becomes, multi-blockchain. The graph network is reading into all blockchain data that's like really relevant, not just Ethereum mainnet, all the other ones that are going to come up in the next couple of years, and connecting them in certain ways and allowing people to really read this data for a reasonable price. The thing is, like, the economics of the graph will, that takes time to figure out, but that's the goal, is to index all this stuff and make data like fair for everybody around the world to access and use. And you can imagine if every single person around the world has the same access to data as everybody else, it really democratizes data in a way. And right now, that's just not the case. Data is siloed in a lot of places, and people, even in wealthy countries, don't really own their data. And then there's all the people in poorer countries who don't even have these privileges. So the hope is that Web3 brings all of this opportunity to the whole world, and then the graph can just help democratize that data and make it easily accessible to everybody.
Dave, you've been so generous with your time, and you've answered a wide range of questions. Thank you so much. For listeners that want to follow your work or stay in touch with you, what's the best way for them to do so?
Yeah, the best way to reach out to me for sure is on Twitter. And my Twitter handle is Dave Kaj, which is Dave and then Kaj. It's just the first 3 letters of my last name. And that's the easiest way to reach out to me. You can also find me on Discord in the Graph Network Discord channel. That's somewhere I'm also active. And that's probably the best. In most public places, you'll be able to find me.
This has been a production of the GRT IQ podcast. You can find additional information, including detailed show notes, by visiting grtiq.com/podcast. That's grtiq.com/podcast.
Please consider contributing to this project and helping build the community by subscribing and leaving a review.
GRTIQ
Podcast. Roger that.